Hello and welcome to this YouTube channel. Today we are going to talk about what is a TLS handshake. Basically, TLS is a process by which a server and a client, they authenticate each other and then they start sharing the data. Okay, so now before we understand what a TLS handshake is, we need to know what is asymmetric and symmetric encryption, because TLS handshake uses the asymmetric encryption. So let's just dive right into it. Okay, so in symmetric encryption, basically what happens is, in very simple terms, a same key is used for encryption as well as decryption. Let me repeat that. We use the same key for encryption and decryption in a symmetric encryption. So if you look at this diagram here, you can see the client has encrypted a data. So this data is the encrypted data using a public key, and now it has taken this encrypted data and the key and it has sent this across to the server. And since the same key is used for decryption, server will decrypt the data using the key that was transmitted. But there is a flaw in the system, which I'm sure many of you must have seen that. If you look at this person here in red, that is our hacker. Okay, this is our hacker. So this hacker, basically what the hacker is doing is it's probing the network. So now in this network, what is it going to find? It is going to find this encrypted data and it's going to find this key. So what is happening here is the server will just decrypt this data. This hacker will decrypt the data using the key. So basically your data is compromised in a symmetric encryption. So it is not that robust, is what you must have understood from this, right? So now what have we done to rectify this? We have something called as asymmetric encryption, which is used by TLS as well. So let's understand what an asymmetric encryption is. So in asymmetric encryption, there are two types of keys. One is a public key, the one in green, that is the public key, and the one in red, that is a private key. So I have tried to explain a small scenario here where you can understand why asymmetric encryption is much more secure. So here, if you look at the server, it has the public key and it has a private key. Okay, so now the server will transmit the public key to the client. So we have our client over here. So the client has the public key of the server now. What the client does is, it takes its data and it encrypts it using the public key of the server, and then it transmits it back. This encrypted data is transmitted back to the server, and the server, now as I mentioned before, right, that this piece of data can only be decrypted using the private key, which only the server has. So once the server receives this encrypted data, it will use this private key to encrypt the data and the server gets the data. Now what does our hacker person do here? So this is actually our hacker. Okay, so now this hacker, when the hacker probes to the network, right, it gets the encrypted data. It can also get the server's public key. But can the hacker decrypt this data? No, of course not, because this data can only be decrypted using the private key, which was never transmitted over the network. So this way, asymmetric encryption, this is how it works, and our TLS handshake basically uses asymmetric encryption. I hope that is clear to you. Now let's just get into the process of how a TLS handshake works. Okay, so before a TLS handshake, the first step is a TCP handshake. Okay, so I know most of you must have already read about it, so I have just in short explained, where the client sends a sync request to the server, then the server sends a SYNAC, basically, where it acknowledges the client's SYN request and syncing request, it sends a SYNAC. Okay, and then it also sends a sync request to the client, like, okay, I acknowledge your sync request, now you also acknowledge my sync request. So the client will also say, okay, I acknowledge your sync request. So thus this means that a connection is established. So let's just write here, connection is established. Alright, so this is a TCP connection as established. So now we are going to actually dive into how the TLS handshake works. So now once the TCP handshake is completed, right, what the client does is it sends a client hello. Now what are the things present in the hello message? Right, so in the client hello, first of all, it sends the TLS versions that it supports. So whatever supported versions are there, it will send that to the server. Then it sends the cipher suites. Basically these are the encryption algorithms, okay, cipher suites that's supported. Okay, so these are the two things which the client sends, and additionally it also sends a client random. We will know what the client random is for. Okay, so this is the client hello message to the server. Now what the server does is, okay, it understands that, okay, the client has sent me a couple of TLS versions that are supported, it has sent me some cipher suites that are supported, and the client random as well. So now the server responds with the selected TLS version. So it selects one of the TLS version from whatever, of course, whatever the client has sent, from that it will select one of the TLS versions. It will send the selected cipher suite, of course. Then it also sends the server random. So the server also has a random message. It will send that. Additionally, it will send the server certificate. So what does this have? It has the public key of the server, and it also has the CA authority. Okay, so this is basically the server hello. So the server hello has sent the selected TLS version, and all of these things are sent. Okay, now what the client does is, it has got the server's certificate. Now it has to authenticate that, right? So now how does it authenticate? What are the parameters that the client checks? So first it will check if it is valid, that is as in not expired. Okay, not expired. Then it checks the valid, if the server is valid, it checks that with the CA that has signed the certificate. Okay, and also it also checks if the domain, it checks the server's domain name. Okay, if it is indeed the server that it is trying to connect to. Domain name. So these are the couple of things. At this stage, if any of these pointers fails, like if the validation fails, right, then the connection will be destroyed. The connection will not go through. So this is what the client does to authenticate the server. So once the server is authenticated, now the client has the public key also of the server, right? So it creates a pre-master secret. Okay, so this pre-master secret is created by the client. Okay, created by client, and what it does is, it will so now this is created by the client. It will encrypt this using the public key of the server. Okay, public key, not its public key. So this is created by the client. It creates a pre-master secret. It will encrypt it, and this encrypted pre-master secret is transmitted to the server. So I will just write here, we have the encrypted pre-master secret, which is sent to the server. Now what does the server do, right? Now server has its private key, right? So it will decrypt the pre-master secret using its private key. I hope this is clear. So now at this point, at this juncture that we are right now, the client has the pre-master secret, the server also has the pre-master secret. So now here what we can say is, server also has the pre-master secret. Okay, so now what both of them do is they create a session key. So now how is a session key created? Okay, so I will write the formula of a session key. Session key equals to, we have the client random, which was transmitted by the client during the client hello, if you remember. Okay, then we will also use the server random, all right, and the pre-master key. So it is a combination of the client random, the server random, and the pre-master key, and a session key is established. So the client, as you must have guessed, the client also does, oh my god, what the hell do I just copy? Copy that and then paste it here. So even the client creates this session key. So now we have our server has created a session key, and it is going to be same because now both of them have the pre-master key, both of them have the client random, both of them have the server random. So when they create a session key, it is going to be the same. So now the client finish will say, yeah, it will send a fin message to the server, right? It will send a finish message like, you know, hey, I have created a session key. Then the server responds with its finish message saying that, hey, what the hell, why isn't it copying? So it says that, hey, even I have finished my task. So now that is how we can say session established. Alright, now we have the session established. So now since both of them have their session keys, they use this session key to encrypt every data, and that is how we have secure data transmission. So I hope you have understood, at least you got a good idea of how a TLS handshake works. And I hope this video did help you, and if it did help you, please subscribe to our channel. Bye bye.